our group is group number 92, and we're going to be explaining some concepts of torque and doing an example problem to help show those concepts with an application to the wrench problem. So torque is basically to rotational motion as force is to linear motion. And it's the rotational equivalent of force exerted about a pivot point. So basically, as you'll see later in the problem, if we're tightening a bolt with a wrench, we usually tighten it with our hand at the end of the wrench. And that's because that's how you do it most effectively, and that force that you exert on the wrench to pull down and tighten it is what we know as torque. So torque is defined as radius times the force exerted times the sine of theta. And in this diagram here, we just put up a little example. So you have the wrench, you have the pivot point, and over here you see we have force being applied, and it's at the end. So like I explained earlier, when you use a wrench, you have your hand at the end of the wrench. So our radius is actually going to be your distance. So we have our distance of 30 centimeters, and we use that in our equation because that's the distance at which the force is being exerted. Thank you.
So in our problem that we're going to discuss today, Sherwan needs to tighten a bolt on his treehouse. He uses a 30 centimeter wrench to turn a nut. The wrench handle is tilted 21 degrees above the horizontal, and Sherwan pulls straight down with a force of 120 newtons. So how much torque does Sherwan exert on the nut? Well, to first solve this problem, we had to draw a diagram to help us figure out all the concepts at work. So first we drew the wrench, which is 30 centimeters. We drew the angle, since the wrench is tilted above the horizontal 21 degrees. And since we know that he's pulling straight down, that is an angle of 90 degrees. We add these two angles and we get a product of negative 111 degrees. But also we had to take into effect that the entire plane is a flat 180 degrees. And so what we do next is we take 180 degrees and subtract it by 111 degrees. We get 69 degrees. So next step we do to find out how much torque was exerted onto the nut is we take the distance. We find out the distance. And so to do this, we convert 30 centimeters into 0.3 meters, and we multiply it by the sine of 69 degrees. You may be asking why we used 0.3 degrees as our radius. Well, because the force exerted onto the wrench was at the end, and the wrench is exactly 30 centimeters, that's why we had to use 0.3 centimeters, or 0.3 meters. And the total of this comes out to be 0.28 meters. Now, in order to find out torque, we take the distance we just found, multiplied by the force. So we take 0.28 meters, multiplied by that by 120 newtons, and we get 33.6 newtons per meter. But we're not done yet. Because Sherwan was pulling at a downward and a clockwise rotation, the answer has to be negative. So the final answer for this problem will be negative 33.6 newtons per meter. I hope this clears up all your problems, and thank you for watching our video.